Good morning, Dr. Bianchini.
Hello?
Hello, can you hear me? Hello, can you hear
Ken,
me?
how are you?
Good, good. Thanks for taking some time to chat with me.
Sure, man. Thanks for
I don't know how good my internet is, so I'm going to go audio only. Okay. Okay.
okay. Can you still see me?
Yeah, I can see you just fine. I just went
Okay.
audio only because I have a relatively weak connection here. So.
Okay, no worries.
Hey, well, thanks for coming to talk with me here. And I was interested in speaking with you. To the audience, I'm talking to Dr. J. Bianchini. Is that correct? Yes. And is that how you say your name? Bianchini?
Bianchini.
Bianchini. Okay, I'm sorry. My Italian is slipping away there.
No worries.
Well, anyway, I wanted to speak with you. You're the COO of Collaborative Aggregates, and I guess of the Werner Babcock Institute.
Yeah, we are. So I was a research scientist at the Warner Babcock Institute for Green Chemistry for many years. And with the development of the asphalt technologies, Delta S and Delta Mist, we decided to start a branch company, Collaborative Aggregates. So we're under the same umbrella. We're still sister companies, but we're a branch off of WBI.
Yeah. Okay. So you branched off from there. Very good. Yep. I'm wondering if your feed will come in better if you go audio only as well, if that's okay. You see down where it says start video, or there's video, and you can
stop video.
There you go. That should work. It's my fault. I'm in St. Thomas right now, so it's I'm staying at a hotel here, and it's just not the best internet, and I'm sorry about that.
No, I'm actually having similar issues here, and I'm 25 minutes from Boston. I think once COVID hit and everybody went home, it seems like everything just slowed down.
Taxing the system for sure.
Yeah, right, exactly.
Are you still at UMass as well?
No. I got my PhD at UMass Boston. So I guess the quick history story. I started my PhD program in green chemistry, and at the time, I believe it was the only PhD program in the world. And I was studying with John Warner, who's considered the father of green chemistry. And I started that in the summer of 2003. And then in 2007, John started Warner Babcock. So myself and a few other of the students went with him to Warner Babcock, and I finished my PhD on the side. And then obviously now we have Collaborative Aggregates.
Well, that's a pretty solid. It sounds pretty solid background for what you're doing now. Can you tell about what some of your focus is, or at least I'd like to start with you explaining what exactly green chemistry is all about.
Well, it's it's funny because we've had folks, and I guess an example is we had a student who started some years ago and in the lab and said, "What are all these chemicals doing here?" And she was under the impression that we would only use water, if you will, and that's not. Yeah, the idea is trying to do it better and keep in mind, the cradle to grave, not only what compounds you're using to make something, but also the byproducts in the synthesis of that material, and then what happens to it after goes out to be used. And then when it's at the end of its useful life, what happens to it when it's disposed of? And a lot of it is it perfect? No, a lot of it's not perfect. And it's incremental steps towards a better way of doing something, better products, and just a better system.
So it's better than what was previously existing, and hopefully future generations we continue to improve and get even more negated like neutral effect of the chemical.
Right, exactly. Yes.
Okay, well that's pretty good. So were you always interested in that type of science, or did you just meeting John was that kind of, well, there you are.
No, when I was an undergrad, I went to Keene State in New Hampshire, and I was looking through, you know, flyers for different grad schools around the country, and I knew I wanted to do something different, and I just didn't know what it was. And then one night, sitting amongst a pile of flyers from, you know, around the country, I came across a guy in the Midwest doing green chemistry, and I was immediately intrigued. I looked into it a little more, and then I started, you know, as I was looking online, everywhere I looked, it always took me back to UMass Boston and this guy John Warner. And the really cool thing was being in New Hampshire. He was only an hour and a half away, so
Sure.
I emailed him and went down and I met with him, and I met some of the students. Some of are still really good friends of mine at this point. And that was, I think, the spring of 2002. No, I'm sorry, spring of 2003. And that was it. I was hooked. I applied to that one program, and I said, if I can't get into this program, I'm going to go get a job in industry. And I got in, and the rest is history.
Wow. Well, that's pretty cool. So I got interested into what you guys were doing because I was looking at, I just told you I moved out to the Virgin Islands, and I've lived in a few different places around the world, and you just see that everywhere, you know, the state of asphalt and paving is, you know, always a concern. And I looked and I thought, how many miles of roadways are there on the planet anyway? I looked it up. It's something like 40 million kilometers of roadways across this planet. And it's massive, of course. So it's an issue everywhere. And you think about how much energy goes into the making and maintaining of these roadways. And to the extent that they are maintained, a lot of them aren't anyway. But I was like, asphalt, you know, has the potential to have some of it recycled, some reused, some of it reused. And I was like, who out there is working to reduce the energy footprint of building and maintaining roadways? And I came across your company here, and I said, you know, you guys actually have been working to develop the Delta S, the Delta Mist, and I want you to talk about what goes into that and what it does for roadways, if you can.
Sure. Well, just, you know, big picture with asphalt, the good news with asphalt is if you look at the top two materials that are recycled most globally, I believe, are aluminum and asphalt. And depending on the source you look at, it's, you know, aluminum's a little bit more than asphalt, and asphalt's a little bit more than aluminum. But that's, you know, being top one or two is pretty darn good.
Yeah.
The problem is that the amount that doesn't get recycled, and this is upwards, both of these materials are being recycled at like upwards of 99%, which is huge. The issue is there's so much asphalt out there that even 1 or 2% that aren't being recycled is just huge amounts. So what we've done is when we started looking at this, there are rejuvenators out there, and the idea is, I guess, I'll you know, explaining how asphalt works in the sense that when you make a roadway, when you take asphalt, what you have is about 94 to 95% stone, your sand, any dust, and then only about 4 to 5%. I'm sorry, 6 to 5% of that is binder, the asphalt binder, and the black sticky stuff.
Yeah.
And, you know, you put that down, and that over time oxidizes. It gets hard. It gets brittle. It doesn't have that pliability that you need in a roadway withstand the impact of the cars, and it starts failing. And obviously that's all scraped up, and then they repave the road. In the repaving of the road or putting asphalt down, you're able to take about 15 to 20% of the old roadway and put it into new construction, without really affecting the physical properties and the performance of that roadway.
Yeah.
When you start going above 20%, the physical properties that the old roadway is putting into the new roadway, what you end up with is premature cracking, premature failure, and you know, the physical performance, if you will, that old material starts taking over in negative ways.
Yeah.
So what we need is a rejuvenator. And what a rejuvenator does is it takes that old material and it brings it back as close as it can be to its original state of performance.
Hmm.
Now there are other rejuvenators out there that are petroleum based, and but we, as green chemists, we wanted to do it differently, and we thought we could do it differently, and ultimately we have done it differently. We've taken a plant based oil with some of our chemistry, renewable feedstock, and what we found is we have a technology that works just as good, if not better, than the petroleum additives that are out there. So it's allowing us to use upwards of 40% recycled content in new roadway without having to bring more petroleum material into that. And all on that, we've gone upwards on small lab stuff of 100% recycled.
Whoa.
But the thing is, it's not that our technology won't allow 60 to 80%, even upwards of 100 to get good performance. It's the way the plants that are currently out there making asphalt are designed, and the production of asphalt, it doesn't allow you to run 100% recycled content. You would have to really build a plant that was designed to do that, and they're just not there. So we would love to go a lot higher. The plants are just physically incapable of doing it.
I can imagine that it's the situation on the ground that's prohibitive. It's not that the technology couldn't exist. It's just that people have to make a big investment in new hardware or equipment so that they could get to that, to be able to do it the way you do it in a lab, right?
Right, exactly. I hope I answered your question. I think I may have gone off in the weeds there. So if there's anything you want me to elaborate on or go back on, please let me know.
To be honest, I followed it completely. I hope that my listeners have been able to follow it. But no, it's a fascinating topic. Can you say, like, how long has this product been on the market, and where has it been utilized most effectively?
The research project, Labscale, my first day in the lab, if you will, was probably 2012, 2013. We officially started collaborative aggregates full scale production in 2015. And we've been all over the country. I have a great map. I don't know if it would be helpful. I could email it to you at some point, but it really highlights our top field trials and experiments, if you will, across the country. I think that one of the better ones that I like a lot, I think it was in Georgia. We did a 48% recycled asphalt mix, which is RAP, and it was it's the highest recycled asphalt pavement project that was state sponsored in the country to date.
Cool.
So that one, and that's holding up great. So that one really is kind of a feather in the cap of what we've done out in the field.
Sure. Now, can you tell me, like, when you're utilizing your binder versus, for example, just the industry standard, where does it come out on a price? I mean, are there savings there by the amount that you can reuse for asphalt doubling approximately?
Yeah, that's a very good question, because when you add recycled content to asphalt, it's essentially free, or it's minimal expense, because what a plant will do is they'll tear up the road in huge chunks, and if they don't have a machine to do it, they have to pay for it to come in, and it'll come in, it'll grind the pavement up, and then it'll get sorted into size, because you need the different size distribution within your mix design, and so it's essentially free. You're taken away from virgin stone, you're taken away from virgin binder. But when you add an additive, whether it's ours or somebody else's, you have to pay for it. So what we found is once you start hitting that 40% recycled content mark, that's when you're going to start seeing significant savings.
Yeah, I can imagine. So
adding an additive. Yeah, and below that, it's kind of, it can be, it's hit or miss, but it's right on the cusp of breaking even. But above that 40% or above is where you actually start saving money, even using an additive.
So I would imagine, just as a business person myself, that the next thing I'd want to be researching in your lab, and tell me if you're doing this already, is what equipment maybe a small public works department would need to purchase so that they could up their game towards the lab performance you're getting, so that they could get to the point where whether they could use like 100% or 90%. Like what basic equipment would they need so that they could get towards that number?
Well, you would you would essentially have to redesign an entire plant. If you don't mind, I can quickly walk you through the production of asphalt so you understand where we'd have to
Okay.
change.
Okay. Yeah. Yeah.
So the first step is you take your stone, your virgin stone, so it has no binder on it, the black stuff.
This is like stuff you just quarried, right?
Yes, exactly. And you would heat it, and a lot of times they just flame heat it, and then they kill the flame or kill the heat, and then you pump in the heated liquid binder, and that's your that goes in, and then you mix it. So obviously you have hot stone, and then your somewhat heated binder just so it can flow, and then obviously the temperature decreases, and when a typical standard hot mix asphalt is mixed at about 325 degrees Fahrenheit. So the stone is flame heated, and then when the binder comes in, they meet at about 325 degrees Fahrenheit. That's mixed and moved on. And then now if you start adding wrap, what you would do is you flame heat, however you're going to heat the stone. Once you kill the heat at that point, you would pump in your liquid binder, your virgin binder, and then you would start dumping in your recycled content. And just a little side point, just the heating, making a 100% virgin mix, just the standard heating of that asphalt binder in that production, you're already immediately at that point, you're oxidizing and aging, and you're losing the physical performance of that binder just by making asphalt. Just a little side tidbit there. And then if you're using like Delta S, you would flame heat the stone, shut off the heat, and then you would inline blend Delta S into the liquid binder as it comes into the stone, and then as you're adding the recycled content. So the issue with using 100% recycled content is you have no way of really heating it without making it worse. Or you don't want to directly flame heat that stuff because the binder's already on there. So it really would come down to how can you efficiently heat that wrap material, get your additive, your rejuvenator in there without ruining it or making it worse.
That's got to be that's real science right there. You got to know what you're doing.
Yeah.
I also was familiar with from years ago a type of Coldmix asphalt known as soup. It's by a company called Halik in Israel. Are you familiar with this?
I'm familiar with Coldmix, but I'm not familiar with them.
Okay. Well, they seem to have been also attempting a green approach at this thing, and by eliminating a heat element of it somehow, then that's another ecological savings on that side. I'll put you in touch with them because it's obviously a different process, but it would be interesting to someone who has your interest.
Yeah, no, we've done many field trials with Coldmix. There's a couple different ways you can do it. You can either tear the road up right then and there, grind it, mix it, and put it right, and add your additive and put it right down, or it can go back to the plant, be ground, sifted, and then you add your Delta, like in this case Delta S, and then you bring it back out. We've had great success. A lot of those cold mix to really be effective because your air voids are greater in those cold mix, and the problem with asphalt is you really don't need your air voids to a minimum, because once water starts down in there and stays in there, especially like where I'm at, the freeze thaw will just destroy it. So a lot of times cold mix people will put it down and we have very effectively, and then they'll cap it with a thin layer of new asphalt just to ensure the water doesn't get to it.
That makes sense. Yeah. Huh. Well, all the incredible science of making asphalt, and I really appreciate you chatting with me for a while about this, and I hope that some people hear this and consider the ways that they can reduce the footprint of their asphalt production. How can people find more information about your company and what you've been working on?
Collaborative is the quickest way to get to us, and I'm up there and the whole team. So it's pretty easy to reach out from there if anybody has any questions.
Are most of your clients are the public works departments then?
No, it's across the board. We work with states, public work, towns, municipalities, and private sector, and we work with say producers and pavers who are sitting in on a bid, and sometimes the town will put out a bid and they'll spec use a green product, a green additive. We want 40%, but your additive has to be sustainable, something like that. So it's across the board.
Okay. Are they? And how do these folks usually find you anyway?
Kind of like yourself.
Yeah.
People that are looking. We also have active sales team, so they're going out and talking to folks and introducing our product. And
yeah, it definitely seems like something that the most important element is just getting the word out. Like if people knew that there's another way that has a lesser impact on the environment and they can do it at the same price, then mostly people would go for that.
Correct.
Cool. Well, I hope I contribute towards that and helped you expand the number of people that are aware of the good work you're doing. Keep it up.
Thank you. Really appreciate it. And how do I how am I able to listen to the podcast or send it to some folks in the company that
I will send you a link and via email, and also I'll post it on Twitter, and it'll be easy for you to share on Twitter if you've got an account.
Okay, great. Well, thank you. I appreciate the time, and I appreciate you reaching out and inviting me to do this.
My pleasure. I'm always looking for people who are innovating in spheres that affect everybody. So,
thank you.
Take care.
All right, you too. Bye.